Hello everyone, my name is Brian Chong and I'm the Pre-Sales Solutions Architect with Micro Focus. Today I'm going to talk about the benefits and usage on correlation between IDS alerts with vulnerability data in ArcSight. One of the main issues I've seen from various customers are high false positives generated by the IDS sensors. Now, tuning the IDS sensors does help and is part of IDS best practice. But organizations are still dealing with hundreds, if not thousands, of IDS alerts on a daily basis. This is where having a SIM, which can correlate information across many different product lines, giving the analyst the ability to correlate information across the similar systems. By correlating IDS alerts with vulnerability data, you can now reduce false positives and only trigger on high fidelity alerts, because ArcSight can now identify if the target host is vulnerable to the exploit the attacker is launching. Now on the screen, I have my ArcSight console open, and I have filter set to show all tipping point Unity 1 events. As you can see that I have several IDS events triggered on my channel. Now I'm going to focus on the Net API Stack Overflow alert, which exploits specific Windows vulnerability. These events were generated when I exploited the vulnerability to gain access to one of my Windows boxes, which I'm going to repeat later on in this webinar. Now, by reviewing the IDS events alone, I cannot tell if the target has the vulnerability exploited by this signature. The only way to know this is if I request the latest scan results from the scan team and going through the results for specific host, which can be extremely time-consuming and not practical when you have thousands of IDS alerts triggered on a daily basis. Now for simplicity, I have number of IDS alerts shown on this active channel targeting various hosts in my network. However, without the vulnerability data, it's difficult to tell if one or all systems were compromised based on the IDS alerts only. All these alerts can be false positives or all can be true positives. So the main message I want to get across is that without the additional context to the IDS events and without the vulnerability data, it's difficult to determine the outcome. Now, there are two fields within any event which plays a big role when it comes to correlation between IDS and vulnerability data. These two fields are the model confidence and the relevance. These fields provide additional context into any event, and ArcSight adds and populates these fields as part of the normalization process. Now, model confidence means if we have modeled the target host or asset in ArcSight, meaning do we create the host either manually or via importing vulnerability scan results into ArcSight. Having a score of 0 means that we have not modeled the target in ArcSight. As you can see, the score for the model confidence for all the IDS targeting number of hosts in my network is all 0, which is telling me that I have not modeled assets in my ArcSight ESM. Now, relevance tells us whether or not the vulnerability exists and whether the target port is open on the target host. Just remember that relevance is only important if model confidence is greater than 0. If the model confidence is 0, then it really doesn't matter what the score of the relevance is, because we don't know anything about the host, so we don't know if it has the vulnerabilities associated with the specific exploit. Additional information regarding model confidence and relevance can be found on the threat level formula. The threat level formula is used by the ArcSight ESM in order to calculate the overall priority of the event. So let me briefly show you where the threat level formula file is at and show you the contents of that file. So here, I'm here at opt ArcSight manager config server. My home directory for ArcSight is opt ArcSight manager. And if I do a listing, there are a number of files. And one of the files that I'm interested in is the threat level formula.xml. So if I do a more on threat level formula, So here it tells you a little bit more in detail about the model confidence and the score that it could take. As I scroll down, talks about the relevance. And then if I keep going further down, this is the formula that ArcSight utilizes to calculate the overall priority of the event. So I would highly recommend that you spend a couple minutes just going over this file and getting a better understanding of the model confidence, relevance, asset criticality, and the priority of the overall event. Now let's go back to my channel here. Now, one of the nice features about correlating vulnerability data with IDS is that where the analyst can easily right mouse click an event and actually find the exploited vulnerability tied to that specific exploit. Now here, the exploited vulnerability and the show target asset has been grayed out because we have not modeled assets in ArcSight yet. So we cannot click on these features. But we're gonna come back to this, and once we have imported the asset model or imported the vulnerability data in ArcSight, these will be not grayed out, and the analyst will be able to see the vulnerability associated with the exploit, and we can also see the attributes of the asset, which will provide us not just the IP address and the host name, but it will also contain the MAC address, ports that are open, and all the vulnerabilities that have been identified. Now that we have seen the IDS alerts in ArcSight without the vulnerability data, we are now going to import the vulnerability data into ArcSight and launch the same attack. Now, due to time constraint, I have already scanned my network and imported the nested scan results into ArcSight. So let's see what this looks like in the ESM. So on the left-hand side in my navigator drop-down menu, if I go to assets, I already see that I have an asset created through a vulnerability scan, and the asset name is acme-hr. So if I double click on this, I get to see the attributes of this asset. So it gives me the name of the host, IP address, MAC address. If I go to the categories tab, it tells me the ports that are open, and it also tells me the operating system. There's also a vulnerability tab, which tells me all the vulnerabilities that have been identified by the vulnerability scanner. So that's what it looks like when you import the vulnerability data into ArcSight. And this is what we mean when we say, model your network with assets. The next thing I'm going to do is that now that I have modeled the assets in ArcSight, now I'm going to change my role to an attacker, and I'm going to attack this specific host, which is my Windows XP box, and I'm going to attempt to gain access to I'm going to gain access through exploiting a well-known Windows vulnerability. Now, I've already done this attack prior to the webinar without importing the vulnerability data. And we saw the IDS alerts shown in the tipping point channel. So what I'm going to do is I'm going to repeat this process again. Now, as an attacker, first thing I'm going to do is gather as much information about the organization and the target. So the first thing I did was I've already scanned the network and found the host that I would like to gain access to. So here is my scan result. Let me just. So I scanned the .150 box, and then if I go to the vulnerabilities, I see multiple high critical vulnerabilities found on this host. And what I'm interested in is the MSOA-067. I mean, this was one of the popular vulnerability within Microsoft operating system. So if I click on the specific vulnerability, it tells you what the vulnerability is and tells you what the CV number is. So basically, the summary for this vulnerability is that uh, that the specific vulnerability allows the attackers to gain root access to the system. So that now that I have scanned the environment, I know what vulnerability is exposed. I'm going to try to exploit this vulnerability now. So in order to do that, I'm going to use Kali. So just to double check, I have my Windows XP box and it has the IP address of 1.50. So this is the box that I'm going to try to exploit and gain root access to the system. Now, I just want to let everybody know that this is not a Kali class or a hacking class. So I'm going to go through this pretty quickly. So first thing I'm going to do is I'm going to do a search on that vulnerability. So here, Kali provides the exploit that I need to exploit that vulnerability. So I'm gonna tell Kali to use that exploit. Oh, as you can tell, I have a typo. It's MS08_067. Okay, so here is the exploit that I can leverage. So now I'm gonna tell it to use that exploit. Okay, now at this point, I have to set some parameters. So I'm gonna type in show options. Okay, so here I have to set which target I'm trying to exploit. So I'm gonna type in set our host. Okay, now the remote port it's using 445 and 445 is the port that it's listening on. So the last thing I'm gonna do is type in the command exploit. It says session 1 opened. So when I do a ls here, I'm seeing a listing of the C colon, and I see that, I see the files and folders located on the C drive for the Windows XP box. So now I have fully gained access to the system, and I could pretty much do whatever I need to do. The next thing I want to do is I'm going to try to also use the same exploit on my operating system running on ArcSight Manager. So I'm going to do show options. I have to exit out. Now I'm going to set the R host to my manager, which is .120. And of course, this is to be expected. It wasn't successful only because the operating system that's running my ArcSight is not Windows box, and it's definitely not vulnerable to that the exploit that I am using right now. Now that I have launched the attack, now I'm going to change my role to a defender. So I'm going back to the same channel that we have viewed before. So now let's go back to ArcSight. Let me just extend my time frame here. Now I see the IDS events trigger based on the recent attack, but now there is additional context to the IDS alert that are targeting .150. So here, if I were to compare this this specific event targeting .150 to the same signature that was targeting .150 before without the vulnerability data input into ArcSight, the difference is that the score for the model confidence has changed. Now, for the latest signature that was triggered, the model confidence is 10 now, which means the asset is modeled in ArcSight. At the same time, look at the vulnerability name. It has done the correlation for us in the background, where it's telling us that this signature is exploiting this specific vulnerability. Now, I have all this information in ArcSight where I could easily look up. So going back to what I was showing before, if I were to just right mouse click this event and select Analyze in Channel, now the feature for Show Exploited Vulnerability and Show Target Asset is not grayed out because these information are now available in ArcSight. So if I click on Show Exploited Vulnerability, on the right-hand side, the Inspect Edit window comes up, and it gives me the vulnerability itself, and you could easily tie it to a knowledge base article as well. The Vulnerability Assets tab tells you which assets are exploitable, or which assets, yes, are exploitable to this specific signature. Now, if I do the same thing and go to Analyze in Channel and select Show Target Asset, then this is where it tells me the attributes for the targeted asset, where it tells me the IP information, MAC address, ports that are open, operating system, and the vulnerabilities associated with it. Now, let me briefly go over, well, let's just go to the SOC channel that I created. And what I did was I created an ArcSight rule that looks for any type of exploit from a known vulnerability. So here, I call the rule remote code execution. And what I want to show is that I want to show the logic behind this rule, because this rule is not just tied to this specific signature that I was leveraging. So if I right mouse click, do a correlation action, and do a correlation trigger, I go to conditions. So here is my logic to detect any type of exploit targeting a known vulnerability. So the model confidence has to be greater or equal to 5, and relevance has to be greater than or equal to 5. This basically means is that any type of exploit targeting a host must be modeled in ArcSight, and if the assets are modeled in ArcSight, then the event has to be relevant to the known vulnerability for the target. So overall, this single rule will trigger on any attack if the target host is vulnerable to the exploit that that attacker is launching. Now, the next thing I want to go over is how ArcSight is able to correlate IDS alerts with vulnerability in the background. Because right now, we saw that it's able to correlate the IDS alerts with vulnerability data. But if we go under the hood, how is ArcSight actually doing this? And where is it getting all this information from? So there are two files that ESM uses to look up the vulnerabilities associated with IDS events in real time. So first, the IDS events are compared to a file called sensor signature. So let me show you that file right here. So when any of the events are processed by ArcSight ESM, it does a lookup of this file, and it looks for device vendor, device product, and the ID number for that specific device. Now, once it gets this information, then it looks at the second file, which is our vulnerability mapping file, which I'm going to bring up next. So here, it provides us the ID number from the sensor signature file. It gives us the signature name, and then it gives us the vulnerability associated with that signature. Now, this vulnerability mapping is fairly large. I mean, if I go to the end of the file, it contains over 1 million entries. So if I were to put this kind of side by side here, let me just do this. So overall, events are processed by ESM Manager. Then what it does is it looks for device vendor, device product, and get the ID number. Once it gets the ID number, then it looks up the second file and finds the ID number, looks at the IDS signature name, and then it looks at the vulnerability associated with that signature. Now all this is processed, and in order for this to work, you have to have asset model in place with ArcSight ESM. And this is all done without a user having to create an ArcSight rule. Now, because the new vulnerabilities are found on daily or weekly basis, and the IDS vendors releases IDS signatures on a regular basis, the sensor and vulnerability mapping file must be updated to detect new attacks. So there is an easy way to keep up with these files. the new mapping files for the sensor and vulnerability are released by ArcSight once a month as part of the content subscription service to keep up with the latest vendor release signatures and the associated vulnerabilities. Now, in addition, these two files are obfuscated, so you will not be able to read it. So what I'm doing is that I'm showing everyone the contents of both of these files in clear text so that you have better understanding of the correlation between the IDS events with the vulnerability data. So these two files are pretty much our secret sauce for correlating the IDS alerts against the vulnerability data. Now, lastly, what if you want an override vulnerability mapping file, or you have a custom IDS signature that maps to a specific vulnerability? So I have seen customers develop custom signatures for various reasons. So this can be achieved as well by creating an override mapping file. So here, what I'm going to do is I'm going to show you a sample of what this override mapping file looks like. Now, the name of the mapping file, it should be signatures.csv. And what you need to include is pretty much on the first column, device vendor. Second column, device product. The third column is signature name or what the value of the device event class ID is. There are times where based on the IDS vendors, the signature name and the device event class ID is the same. Other vendors, it maps differently. So what you want to do is when you have a custom signature, look at an ArcSight, open up a console, and look at that specific signature. Look under the field device event class ID and see what the value is, and that's what you want to include here. And then the fourth column, you want to include a vulnerability associated with that the signature ID. Now, once this file has been created, then you want to place it under the manager home user manager directory. So here, I'm gonna then you're gonna go to CD user. So the override mapping file should be located under opt ArcSight manager user manager. Now the whole vulnerability correlation is automatically done by the ArcSight ESM, and it needs the following to work properly. So I have 4 things that you must do. So one, your assets needs to be modeled properly. If you check the IDS events and the model confidence is 0, then you have an issue. So any IDS events you get, if you feel that you have modeled your assets successfully and you see an IDS events targeting an asset and the model confidence is 0, then the asset is not modeled in ArcSight for some reason. So you got to make sure that the assets are modeled properly and successfully. 2, you need an up-to-date vulnerability mapping. Now, this is part of our content subscription released on a monthly basis. So you got to make sure that once it's released, you place it in the a certain directory within ESM. Third, your assets needs to be modeled properly. This goes back to the number 1. I'm kind of repeating what I stated there. And then, of course, you also need to update your scan results frequently. So every time there's a scan going on, anytime there's a new scan, you want to import the latest scan data into ArcSight for the latest results. So overall, correlating IDS alerts with vulnerability can dramatically decrease the false positives within IDS, which can save time, money, and resources. because analysts don't have to spend time investigating false positives. You want the SIM to automatically read out false positives so that they can focus on high fidelity indicators. So I hope that you have a better understanding of how leveraging the correlation between IDS alerts with vulnerability can decrease false positives and save time and money. Thank you.